The last artifact that I'll be talking about is my reaction rate inquiry lab. So a little bit of context about this piece is I completed this artifact last year in chemistry, and it was a science lab. And the essential question that we were answering is a little bit long, but makes sense. Does the speed in which you stir H2O2 into hydrogen and oxygen affect the reaction rate of decomposition, and does the movement of particles play a role in this? So the process that I went through was in class. Mr. Wild, Mr. Wild was our teacher that was teaching us. He kind of had us learn this material on our own in a way. We had to learn about hydrogen peroxide, and he didn't teach it to us in class. Instead, he gave us a worksheet and said, these are the things you need to know. You need to know why it's important that we learn about this, how is it related to our bodies, and why is it important that our bodies decompose it. And he just said, you know, there's the internet. Use your resources and find the information. And so I went and I used a lot of, there was a science website that he gave us. I don't remember exactly the name, but I know that's the one I used mainly. I used Wikipedia, not as much because it's not so reliable, but mostly all websites. I didn't use any books. And the necessity of breaking it down. Basically, too much hydrogen peroxide in our body is really bad for us. Well, too much of anything is bad, but too much of hydrogen peroxide specifically isn't healthy. And if I'm not mistaken, enzymes are what help break it down, and enzymes in our body are what allows us to do simple stuff, daily tasks like breathing, eating, swallowing, and they serve as a catalyst for the reaction rate of hydrogen peroxide. So we did a lot of research to learn about the topic and how it's related to us, and we read several articles and found evidence individually, which is what I was talking about. He gave us an outline, and basically we filled it out with all the information we were acquiring. And in class, what we did was a lab. We worked in groups, and this here is a magnetic stirrer. So what we did is we had a beaker, and at the bottom was like a magnetic bean, if you can imagine that. And then once you turn the knob, the bean starts spinning slowly in the beaker, and we have hydrogen peroxide in the beaker, and then we have the beaker covered by like a probe, which is made out of, there was a plastic one and then there was a rubber one. The rubber one made sure that the air didn't escape, and so then the whole point was to see how fast the hydrogen peroxide would decompose inside the beaker. The pieces that are highlighted are all the websites that I used to get the information that I needed for my background, and so this later I'll use as evidence. So connecting this piece to my thesis, it allowed me to learn to be a strong group member even in unenjoyable situations. So science is not my favorite subject. It's really not. I just don't enjoy it. It may be one of my strengths, but it's not my favorite one. And so having to work in a group with other people who don't enjoy science was a little bit difficult, because it kind of leaves with, okay, how are we going to get this done? So in that role, I had to learn to be a strong group member, kind of step up to the plate and be like, okay, I don't like to do this, but we have to do it anyway. Mm-hmm. And it helped me grow as a person and just realize that I'm not going to enjoy every situation that I'm given, but I have to make the most of what I'm given. It also helped me learn that everything teaches us something, and it is not necessary. No, and it is necessary even if we don't enjoy it, because this allowed me to learn what I needed in order to pass my chemistry class, and so it was required. It also helped me learn a little bit about my body and the necessity of breaking that down. I just didn't know about that before, and we may not enjoy it at all times. I hope to be an example to my family through that, because I know my little sister doesn't enjoy certain areas of school or school in general, and so I hope to teach her that even though we don't enjoy it, it's necessary. Like learning to read and making sure that you're proficient at it is necessary even though we don't enjoy it. And so I learned to use evidence, which was why I had highlighted all of that, in order to build validity. And so this will help me when presenting information, because evidence is crucial. I can't just present a bunch of information to people and be like, yeah, you need to go to college because it's going to help you. So I know that for the people in my church specifically, most of them graduate high school and go straight to getting a job. And so if I expect them to want to go to college, I need to show them proof that there is a benefit in going to college. I can't just expect them to like leave their work and then go for something that they don't think is going to benefit them. So that would definitely help me learn that evidence is crucial. The leadership skill that I used was collaborating productively, of course, because we worked in groups. I actively contributed. We came after school and to finish the project because we fell behind at first when we realized we had to get it together and just get it done. I supported other group members, specifically Alacia. We both do not enjoy science, and we both were in the same group. And so we kind of had to just support one another and really get this project done. I also identified members' strengths and took them into account. So I noticed that one of our group members was really good at collecting the data and really good at making sure that everything, the experiment and the lab was set up in a way that it was supposed to be set up. And that helped me realize that, you know, I can assign them that task so I don't have to do everything. And then it realized that my strength is kind of recording all the information and explaining it to them so that they're later able to do their own lab report. We distributed the work evenly. We even came after school, as I said, and so this all worked in collaborating productively because in order to get this project done, we had to work in a way where we were going to be productive.
How exactly did you learn about the importance of evidence in this lab? What was it that taught you that specifically?
Well, in science, most of it is all based on facts. It's like, you can't just make up why hydrogen peroxide is important in your body. You can't say, oh yeah, if you don't digest it, you're gonna get some kind of sickness. Like, it's all factual and it all has to be supported. The whole purpose of the background of the science lab is to kind of give background information to the reader so that they understand the whole purpose of the lab and why it's necessary and what you learn or what they need to know in order to understand it. And so I wasn't just going to put a bunch of information and expect them to believe it was true. I actually started like that, and Mr. Wild was like, I could just say that you made this up. You need to actually prove that this is correct and how you know that. And so that is why I put in the websites. So it was actually a little bit through Mr. Wild and then realizing that it is actually important.
What were his requirements in terms of sources? So, were you allowed to use Wikipedia?
He said that you were able to use it, but it couldn't be your main source. He provided me with the rcsb.org. Wikipedia, this one really presented it in a complicated way, so that's why I used Wikipedia, but I made sure to only use it once, and there. But I try not to use it often just because it isn't as reliable, so that's why I put in the enzyme essentials.
So where is hydrogen peroxide found in the body?
We use it to digest, so I would have to say in the stomach area.
What were some of the sources of error in this lab, and then how did it affect your data? And then also, what could you do to reduce those sources of error?
One of the sources of error that I remember having was that the probe that goes at the top of the beaker, the one we had initially had a hole in it, and we didn't realize it did, so our complete experiment wasn't working. It was actually it was really tiny, so it was hard to notice it, but it was allowing air to come out, and so our data was like all over the place. And so we just thought that's the kind of data we're supposed to have, and so we went with it. But once we started trying to form conclusions and starting to like put it together, we were like, this is ridiculous. Like, there's no way that this makes sense. And so that's why we had to redo that. So that was one of our errors, and it affected our data and our conclusions, but we went back and we redid it all, and so that's how we fixed it. Another source of error was that the timing, when you stopped, it was a human error, because we had the same person stop it and start it every single time to try to avoid that. But also it's hard to be like right on the dot, especially when it's like seconds. And so sometimes we did go a little bit over, a little bit less of how much we timed the magnetic stir. And so that was another error that changed the data a little bit. And then the last one is if you go to like this one, we had it on specific speeds because our independent variable was the stirring speed. we said that the faster, if you change the stirring speed, then the rate at which it decomposes, or the rate at which the reaction occurs, is going to change. And so we had 3 different speeds. We had one at low, one at medium, and then one at high. And so the thing is that the little knob didn't have any indication of where it was pointing. So it was kind of through estimation that, oh yeah, this is medium, and trying to remember how fast the stir was going. So this was one of our errors, because I think one of the times it was a little bit faster than usual, and so our stirring speed wasn't exactly consistent each and every single time.
So if you were to redo the lab?
I think we would ask for permission to mark the probe.
And what about that human error issue with the timing? What could you do there?
That one would be difficult just because it's a person. I think just try to get it as close as possible.
How can you make the jump from a stirring bar versus like an enzyme in your body?
So the more pressure that built inside, and the faster it built inside the beaker, it meant that the faster the reaction was occurring. And so the magnetic beam stirred the hydrogen peroxide inside the beaker, and so it kind of served as the catalyst for the reaction. And so enzymes serve as a catalyst for the reaction in our body. They're kind of what allow or start the reaction of hydrogen peroxide in our body. So it kind of was a representation in the experiment.
And so why were you measuring pressure?
Hydrogen peroxide is a combination of water and oxygen. So in breaking it down, it would separate into simply water and oxygen. And so because we weren't letting any air out, there was already air in the beaker, and then the combination of the oxygen would increase the pressure. So we needed to see how much pressure was in the beaker, and if the pressure increased, that means that the reaction was actually taking place.